of this telescope, of this remarkable instrument we put in space, is finding things that we didn't expect, that we can't explain, because that means that we have to revise our understanding of the universe.
Will the history of astronomy be divided between before Webb and after Webb?
Yes, I believe it will be.
So something real is happening, but we can't tell yet if it's a mistake in our observations, a mistake in our interpretation, or just something nature is surprising us with, such as a new kind of dark matter, a new kind of dark energy, or something else that would be really exciting to discover. So if there's a Nobel Prize in here, that could be one of them.
Something truly perplexing is unfolding in the early universe, leaving scientists baffled as their established theories struggle to make sense of these mysteries. Thousands of peculiar objects have emerged in deep field images captured by telescopes, and astronomers are at a loss to define exactly what they are observing. These enigmatic entities defy classification as galaxies, as they appear fundamentally distinct from what we understand early galaxies to be. To add to the intrigue, the James Webb Space Telescope recently peered beyond the so-called dark ages of the universe, revealing astonishing structures that have shaken the foundations of cosmology. Most cosmologists agree that the universe originated approximately 13.8 billion years ago. Yet, these strange discoveries seem to challenge that timeline, potentially prompting a seismic shift in our understanding of the cosmos. Some Nobel laureates have even proposed revolutionary theories suggesting that the universe may never have had a beginning at all. Instead, what we perceive as the early universe might be something entirely different, something we have yet to comprehend. Under the standard lambda CDM model, which incorporates cold dark matter and dark energy, these findings raise serious questions. For instance, many of these newly observed objects appear impossibly massive for their estimated age. The sheer number of stars they host suggests that nearly all the ordinary matter in the universe would have had to condense into these structures, but that scenario seems implausible, given the known limits of ordinary matter. So, what exactly has the James Webb Space Telescope uncovered at the farthest edges of the universe? And why are scientists saying these discoveries could revolutionize everything we thought we knew? For nearly a century, since Edwin Hubble's groundbreaking discovery in 1929, we've known that galaxies are moving apart due to the expansion of space itself. But this cosmic expansion is proving to be far more complex than we ever imagined. The universe has no central point. This means that no matter where you are, it seems as though everything around you is moving away, almost as if you're at the very center of the universe. But here's where it gets more fascinating. Scientists have discovered that space is not just expanding, it's accelerating. This implies that galaxies farther away are receding faster than the ones closer to us. Imagine Earth is positioned here. Using the James Webb Telescope to peer into the cosmos, we observe that everything appears to be moving away. Now, because distant galaxies are receding faster, there's a point in space where galaxies are moving away at the speed of light. Scientists refer to this boundary as the Hubble sphere. Beyond this, galaxies are receding faster than the speed of light. You might think it's impossible to see these galaxies since their light can't reach us. But surprisingly, that's not the case. Thanks to the accelerating expansion of the universe, the Hubble sphere itself is growing. This ongoing expansion allows us to observe galaxies beyond this threshold as they enter our view over time. However, there is a limit to how far we can see, defined by the observable universe, an immense region spanning approximately 92 billion light-years across. At the very edges of this observable universe, we find a faint glow of the cosmic microwave background radiation. This radiation represents a snapshot of the universe's infancy. In fact, when we look into deep space, we're essentially looking back in time. For example, the farthest galaxy identified by the Webb telescope, named Jade's GSZ 14, existed when the universe was only 290 million years old. However, this galaxy has since moved beyond our observable universe. Today, we can no longer see what it has become, as its light will never reach us again. Yet, the universe stretches far beyond what is observable from Earth. Beyond our cosmic horizon lies an uncharted expanse filled with galaxies and stars that extend into infinity. It's essential to remember that the observable universe's boundary is relative to our vantage point here on Earth. For species located elsewhere in the universe, their observable universe would have a different volume than ours. According to the standard cosmological model, roughly 14 billion years ago, the observable universe and everything beyond it was compressed into an incredibly tiny, infinitely dense point known as the singularity. But hold on, that's not the full story. This idea assumes the universe is finite. If, however, the universe is infinite, and evidence suggests it might be, it would have always been infinite. In that case, the Big Bang didn't occur in one particular spot. It happened everywhere, all at once. This means that the first galaxies didn't emerge in a specific region. They formed everywhere, even in parts of the universe beyond what we can see. It's as though matter sprang into existence across the entire cosmos simultaneously. The cosmic microwave background radiation, the faint glow we detect from every direction in space, represents the first light emitted by matter. It's a snapshot of the universe's infancy, a crucial piece of evidence for our theories about the cosmos's size and origins. But recently, discoveries made by the James Webb Telescope have put these long-standing theories to the test. Initially, scientists expected the Webb telescope to spot the earliest stars and galaxies at the very edges of the observable universe. Yet, to their surprise, the telescope detected peculiar bright objects that didn't align with the characteristics of early galaxies. A recent study published in the Astrophysical Journal identified 87 galaxies that might have existed just 200 to 400 million years after the Big Bang. This revelation has baffled scientists. According to current theories, the universe shouldn't have been able to produce so many galaxies so quickly. Haojing Yan, an astronomer and co-author of this study, stated that if even a few of these galaxies are confirmed, it would challenge everything we know about early galaxy formation. Take, for instance, this extraordinary image. It depicts a unique early galaxy that defies our understanding of how galaxies evolve. Typically, galaxies contain gas and dust that orbit their center, essential ingredients for star formation. Observations show that at most, only 10% of a galaxy's gas typically transforms into stars. However, the Webb telescope recently identified 3 galaxies from the early universe that break this rule. Spectroscopy data revealed that these galaxies converted 100% of their available material into stars, something thought impossible based on current cosmological models. These findings have left astronomers puzzled. How could these galaxies form so early? And why do they deviate so drastically from theoretical predictions? Some researchers now speculate that these objects might not even be galaxies, but entirely new phenomena we have yet to comprehend. If these objects are indeed galaxies, the Big Bang model itself may need a fundamental revision. The Big Bang, as currently understood, cannot account for galaxies like these forming within just a few 100 million years. In truth, we still don't fully understand what these mysterious objects are. That's all for today. What do you think these objects could be? Let us know your thoughts. And don't forget to share this video with others who are fascinated by the mysteries of the universe.